Hello, everybody. I'm glad to see you on Math.random community channel. Please follow us on YouTube and Telegram. And today we are going to talk about life, about technologies, about career, about architecture, about product hunt. I hope everybody knows Product Hunt. As for me, it's one of the favorite places in the internet, place where ideas are growing, place where startups can find first users. And best person who can tell us about technology side of Product Hunt is the head of engineering, Radoslav Stankov. Hello, Radoslav.
Hey, thanks for having me. Really excited to be here.
Before we start talking about architecture technologies, let's talk about you. Could you please tell your story? What your career path had been? How did you become head of engineering?
Yeah, so I started in technology. My first programming job was when I was like 15. It started kind of like a joke. And now 18 years later, I'm still doing the things I started back then. And I'm actually in Product Hunt for like quite a bit of time. I'm like here for like 6.5 years now. It's quite a bit. Originally, my goal was okay. I was just between jobs, and I was thinking something fun and interesting, and I really liked the team. The head of engineering back then, Andreas, we worked together in a previous company, and my original plan was I would just spend year, 2 years, just set up the technology stack, set up everything in the company, and just move on when my job is done. And 6 years later, I'm still here. So yeah, that's a very short version of my path so far.
Okay. Now you're head of engineering. It sounds like a balance between engineering tasks and managerial tasks. What is the balance for you in Product Hunt?
So right now it's kind of shifting. Like if you asked me like a year ago when we were smaller, I would have said it's like kind of 50-50. Now I'm mostly moving into more management, architecture, high level things, and mentoring and coaching instead of just doing pure engineering work like implementing features, implementing things. I'm still doing this time to time, but I'm mostly focusing on details and high level pictures, just connecting the dots and mentoring my team and help them grow.
I see. What are your career plans and goals for now?
To be honest, as I mentioned, I'm not very good at career goals and plannings. My original plan for 1 year became like 6. So right now, my biggest focus on the career level is, again, I want to help Product Hunt grow. We are right now back in the growth trajectory, and I have a couple of team members which I want them to grow and succeed quite a bit. I have big scope for them. I mean, I have hope for my whole team, of course, and I want to grow the engineering organization. I want to bring it to a state where uh, we can execute faster than we currently are, a lot more reliably, and with a lot less dependence on me. There is still a couple of things in the company that has to go to me right now, and I'm in the process of removing myself from the process. I want to focus more on a high level things, more architecture things, and mentoring, and my team to do most of the work in a good way, like grow them so they can take a lot of the responsibilities I have. So that's my kind of goals for the next year and a half. And I don't plan more ahead because it's never works out.
Okay, it's clear. So I'm going to create your professional portrait, and I have a set of questions what you could answer briefly. Let's start. Are you a morning person or a night owl?
I'm both. I'm recently started waking up quite early, but historically I have used to be a night owl. So right now I'm just switching between those modes every 2 or 3 months.
I see. Are you coffee or tea person?
Coffee,
Okay. Rakia, wine or beer?
beer,
Okay. So
especially Belgium wine.
I see. Nice choice. Uh, it, it was warm up. We completed and moved to the technical questions. Your first programming language?
My first programming language was called Pascal, but the real one was PHP, the one which I actually got my first job with. Pascal was something I was being taught at school very early on.
Your favorite programming language?
I would say Ruby right now.
Okay. Linux, Windows, or Mac OS?
macOS.
Okay. Your favorite IDE?
I'm Vim user. I don't use IDEs.
Okay, but anyway, do you like dark or light theme?
Dark or
Or
light?
macOS?
Oh,
Yeah.
yeah. I use a light theme. My theme is the same theme GitHub uses for their white theme of color coding, because I switch a lot between GitHub and Vim. So I use the same theme.
Okay, okay. Monoliths or microservices?
Depends. Like, depends on the situation. I don't have any particular choices. Product, for example, is mixture between monolith and microservices. Like I like mixture.
SQL or no SQL?
SQL,
Okay. Chrome or Firefox?
Chrome.
Last one question from the set. Elon Musk or Martin Fowler?
Elon Musk.
Okay. So we completed this set. This set. Next question: what is, what in your opinion, the most important quality for an engineer?
To be reliable. Like, for me, the most important thing for engineer is for them to be reliable. And by reliable, I mean they should understand one thing above their stack and one thing below their stack they're working on, and they should deliver consistent results. They should be able, when they say, okay, I have a task, I would execute it. Or if they know they won't execute it, or this is a lot above their skill level, they should be asking for help and getting help, or grow to the level they need to be. For me, it's very important, some people, to be reliable.
Okay. Let's probably move to the architecture. And could you tell us about its creation? Probably a little bit about starting position, context, about main issues, quality, significant quality attributes.
About the product and architecture.
Yeah, we are going to talk about product.
Yeah. Yep. Okay, let me do a quick share of my screen. I will just walk you through our architecture. I have prepared a couple of images from our internal and public documentation. So do you see? Okay, just a sec. So do you see my screen?
Yeah, I guess you can see it as well.
Yes.
So
yeah. So this is the product and architecture right now. I have excluded all the microservices because they're quite small and large. But most of the way product hunt works is we are hosted in AWS. In front of us, we have the Cloudflare, and we have a couple of services in our system. Like, we have a front-end server-side rendering service, which is with Next.js. We have a GraphQL RubyOnRails API. The GraphQL API is driven by RubyOnRails. We use Redis as a message bus, and we have a background workers all written in Ruby with a library called Sidekick. And we have multiple microservices. One of these microservices, they are mostly written in Node.js. I mean, mostly all of them are written in Node.js. One of them is called webhooks, for example. It receives webhooks from internal services, puts them in a message queue, and then Ruby service handles them. Every service, we use Docker for every service, and every service is deployed via Elastic Container Service of AWS called Fargate. And for storage, we are very simple. Like we use Postgres SQL as RDS Aurora. We use Redis for caching and for some application data and for message bus as well. And we use S3. One other service which is very important for us is called ImageX, which sits in front of our S3 buckets and serves our images. So this is the high-level overview of our tech stack right now. This is something which is copy-paste from our internal documentation. And this is, for example, when a web request comes to the production, this is all the things that happen to this web request. The browser first hits Cloudflare. The Cloudflare then hits the AWS Elastic Load Balancer. Then it hits our front-end service, which is Next.js, which renders our React. For the first render, it makes a GraphQL request to our backend, which is also an Elastic Container Service, and it's RubyOnRails. Then, depending on the request, we are either hitting a cache in Redis, or we are making an SQL query to RDS. Then we return a JSON response to the backend. The front-end service renders the response, and it returns an HTML to the browser. So this is our architecture, and this is how a web request passes to our system. Let me stop sharing. So this is like the bird's overview of our architecture.
But what kind of issues or main task you face it with before you start implementing the architecture? How many people use Product Hunt, or probably security issues or something like that?
Yeah, so we have millions of users. Big chunks of our traffic is not logged in users. So a lot of our system is used by not logged in users. So a lot of the traditional scalability of like, okay, if it's a logged in user, security things that work for us. For us, the biggest problems are around right now around performance. And as you noticed, because we are jumping through multiple layers, it's interesting to trace, okay, which is the slower layers, how we can optimize the flows, and where we can put the different performance layers. Like this architecture is the fastest we have. We had a couple of iterations where the different pieces were, for example, some of them were in Heroku, others were in Amazon. We moved back and forth there. We were experimenting with having single server, which hosts the Ruby and the Next.js service. And before Next.js, we had something else. So this was the biggest challenge for us, was performance of the system, how we can reduce that. And because a lot of our traffic comes from not logged in users, and our system doesn't need to be up to date for those users. So some things we do is we cache Product Hunt. So you see, so if you are not logged in, or the first time you visit Product Hunt, you see a cached version from Cloudflare. So you're not even hitting our servers. We just serve you the old version, like 5 minutes, 2 minutes, 3 minutes. We toggle this quite a bit. And it's not critical for our site, and it helps us being really fast. We do a lot of HTTP moving of assets to Cloudflare. We use ImageX to optimize a lot of the images. Like Product Hunt is a very image heavy site, so we put a lot of effort into optimizing image, and that's the reason, one of the main reasons we use ImageX. They helped us optimize images. Like for example, the best way to present images is WebP, which is not supported on mobile Safari, for example. So ImageX is smart enough to know that. So, for example, when an image comes, they can optimize it. they support different ways to give that. So this is stuff we optimize. We optimized a lot of our front end to give you the smallest chunks possible, and this is done mainly to Next.js. They have like an amazing code splitting strategy. On the back end, again, we focus on the GraphQL and having ability to auto scale depending on the traffic. So for example, if you get a lot of traffic, if it's a front end traffic, it's handled in the front end. If it's a back end, we can just spun up multiple back end servers of the Rails monolith, which is the heart of the application.
Mm-hmm.
So this is the way we handle a lot of those places. And right now we have two internal processes. So on the company level, we think in quarters. So we have a team which is called platform, and this is the team which is enabled for big platform changes. And the goal for this quarter is for them to focus on the backend performance, because this was a bit neglected in the last couple of years. And we are working a lot to improve the way we monitor stuff. So we know, for example, a request comes, what's the life cycle of this request? Because we use GraphQL, we want to know on per field GraphQL level, which is fast, which is slow, where we should add cache, where we should add more logic, what we should remove on the application level. So this is the biggest technical challenge for us, performance. I can talk about developer productivity and security if you don't have any follow-up questions about the performance.
Okay, thank you for explanation. I had a few questions related to architecture. I didn't find some blogs related to full text search. Do you use it on Product Hunt? I didn't use it on Product Hunt, but anyway, probably you have it.
Yeah, so with the full text search, we are using a third-party service called Algolia, and just for the full text search. And we are still researching, should we go to Elastic or not? There's pros and cons for both situations. Right now we have an internal project which we actually investigate areas around that, but we use a third-party service. And the way the system is architectured for the full text search is that, for example, if we want to switch to something else, so just let me step back a bit. One core value of the way we are architecturing things a lot internally on the code structure is to have pieces that are replaceable. So for example, if we want to replace something in our stack, we don't need to make big changes. And a good example of this is our full text search. So the way we use Algolia is we have a couple of functions that we just passed an input and they give us result, which comes from our database. Like we go to Algolia, the result from Algolia, we just get the IDs, and then we get our data from our own database. So if you want to switch Algolia with something else, we can just change those two functions, or three functions, I don't remember the exact number. We also have a system which allows us to export records to Algolia. It's just a simple class, which you just include in a Rails model, and it starts automatically sending changes and syncing those changes. And if we want to, for example, go to something like Elastic, we can just, okay, the service now sends data to Elastic and not to Algolia. So if we need to do the changes and Algolia doesn't scale for us, or we change this very easily.
Okay, clear. What are you using for authentication and probably user management? Is it your internal system?
It's an internal system. So for authentication, we use OAuth with Google, Apple, Twitter, Facebook, like AngelList, like the stuff. We use Ruby library. There is an awesome Ruby gem called OmniAuth, which handles all of this for us. So we don't care about like the technical details. And for user management, it's written system by us. The whole user system is written by us.
Okay. You mentioned that everything what you have packed in containers in Docker. Are you deployed
Yes.
to Docker or Docker Swarm or like that in EC2?
Yeah, so we use AWS Fargate, which is it's AWS's Kubernetes. You can name it like that. It's just it's a managed service for running Docker containers, running them in groups, and everything gets run to there. Like we just put a container in Elastic Container Repository of AWS, and they spun up tasks, and they manage all the traffic between those tasks.
So how often do you review the architecture, and what needs to happen to trigger changes in your architecture?
So, I mean, we constantly adjust things, but in the last couple of years, it was very stable. Like the last major architectural change we did was in January when we changed. No, actually, the last big architectural change is the one we are going to do next week, actually. So what we have with the architecture, it's more like we don't just say, okay, every 3 months we're going to do a big architectural change. It's more like what the pain points we have. Like we have a dedicated platform team right now in the last 3 months, just for this reason. We have pain points, and how can we adjust our architecture to fix those pain points? We don't say, okay, let's revisit the architecture. We revisit the architecture constantly. And there is things in our architecture where we want to change and we want to adjust. For example, we were having our own server-side rendering service written by us, which was not optimal, and it had a lot of issues. And we decided to switch to Next.js. And we used that opportunity to also switch to TypeScript. So for us, this took like a month and this was a big major architectural change, but the way the front end was written, everything was isolated. So the front end actually did that. Right now, it doesn't know it's using Next. It just knows I use those 5 primitives. The next architectural change, the one we are doing right now, is because everything is in Docker. We have one very big container which have everything we need, and it's slow to deploy, it's slow to span out, it takes a lot of resources. So right now we are splitting this big Docker image into smaller images for anything where it's needed. So, and the pain for this is auto scaling and the deployment speeds. So this is something we wanted to adjust. So the way we think about architecture changes is there any pain? Is there anything which is hurting us? Is there anything that we are frustrated at? And we fix it.
So what has changed since the implementation of the architecture, biggest thing?
Oh man, I mean, originally, like when I started at Product Hunt was just a Ruby on Rails app. It didn't have React. It wasn't on AWS. It was just on Heroku. It had like 2-3 services. It 2-3 task workers there. It was it wasn't Dockerized. It was just like a standard Ruby on Rails app 6 years ago. And slowly over the time, we added React. We make Product Hunt a single page application. We moved it from Heroku to AWS. We then started using Docker. We Dockerize it. We started splitting chunks of Product Hunt to services. We added GraphQL as a communication layer opposed to like the traditional REST. We implemented, and again, right now we continue with this iteration. So I don't think we ever did like a big revolution. It's more like evolution. Like all the things we did with our architecture, we never said, okay, we are doing a big bang, just start from scratch. We were always, okay, we have something that works, but we want to make it to work better. What's the steps we can take to fix the immediate pain and move the architecture forward? So we always have like, okay, where we want to go. we had another great opportunity. Like we worked on a project called Your Stack, which was a brand new system from scratch, which happened very rarely. And for that, we tried some new architectural approaches. We tested some things, and a lot of them worked. Like, for example, this new Next.js, the way we are structuring Docker is copy-paste from there. But for example, there we tried to use Kubernetes. It was fun, but to be honest, for our needs, Fargate is good enough. So we stick with Fargate. And that's our approach in general. We try to isolate things to make them easier to change. And then we don't do big changes, we just do incremental changes. And when we do the incremental changes, stuff just improves over time.
So when you start choosing new technology, what kind of criteria you use for the choose?
So for me, I'm getting colder and I'm starting to get a bit more, okay, I'm not going to use the new hot technology. And that being said, I'm using GraphQL for 4 years now. I'm using React for 6 years now. And right now we are switching to it turns out we use a lot of new technologies. But what the common thing is, when I think about new technologies, I don't use the new technology just for the sake of it. It's like, what fundamental thing this technology has compared to what I already have. Like, for example, GraphQL was a mind-blowing thing for me. It's like one of the best technical decisions was to switch to GraphQL because it fundamentally changes the way we interact. Switching to TypeScript, we used to have flow type, which had some type annotations, but they didn't work very well. And TypeScript fundamentally changed the way we actually organize stuff. So for me, it's I want technology that solves a very concrete problem and make my life easier, makes my work easier. It's not just because it's new and shiny. Like, for example, I have a lot of friends right now which are checking out this framework, Svelte, and I'm checking the framework to use it. It's cool. It has some great ideas. It solves some problems which I have, but not any big major problems fundamentally that I am right now facing with React. And the thing for me is I want something that solves a fundamental problem I have with the way I'm building technology. And for example, one newer technology which we use is React.Native. We use it for the last 2 years. And it's a new technology, it's a proven technology, but it solves a fundamental problem that making native UIs is really hard in terms of just engineering time. So I always just care about that. What this technology can do for me. I don't care if it's new or shiny, because usually new and shiny, that means buggy, that means unproven, and that means I need to learn the fundamentals and migrate services to it. And I don't want to migrate just for the sake of migrating.
Okay, interesting. How does the development process looks like in Product Hunt? How fast this process from idea to deployed code?
We're really fast at getting stuff to production. Usually we get 2, 3, 4 deploys. Almost every engineer deploys at least every 1 to 2 days or 3 days at max. So couple of caveats. Everybody on my team is a full stack engineer. And the way right now I'm thinking about this is, when you take a feature, you start from the database design, Ruby backend, GraphQL API, React frontend, CSS, and product decisions. You have to build the features. Of course, not everybody's expert in all of those areas. If you need help. But the idea here is you should be able to be focused to ship your feature. And my philosophy is reduce blockers. And those are technical blockers, business blockers, product blockers. You should be able to ship feature quick and fast in a single player mode, collaborate again with other people, but you shouldn't wait on anything. You shouldn't be just a front ender just waiting, okay, I'm waiting for the API. When is the API going to come? or you are a backender, you're done, and we're waiting for the front end to be implemented. Or even worse, it's like, okay, I need some changes to the server architecture. I don't understand that. Okay, let's talk about it and let's ship that. And my philosophy is just ship it, like have that. And the collaborative part in our work is we give you a lot of safeguards. We have a review process, like every code change goes to a PR review process. We have a lot of automated linters and style guide code checkers. Like we use something called Rubocop in the Ruby land. We use ESLint and Prettier in the JavaScript land. We use TypeScript for type safety. So you know that your code is up to the coding standards, it's formatted well, it's type safe on the TypeScript and GraphQL side. We also are focused a lot in having automated tests, like your feature should have feature tests, not only unit tests, but feature tests, like a feature which opens up a browser, starts clicking, things work, and
what do you use for feature tests?
So feature tests, we used two in the Ruby land called Capybara. It's an RSpec, like this is RSpec is a very standard testing tool in the Ruby land. So it's a very simple, and I mean, I use this tool for 10 years now, where it opens headless Chrome and it starts, and you can say, okay, click on this button, click on this button, click on this button, click on this button, and like assert that, check if the record is in the database, and it can even make you a screenshot. The other nice thing is we have a convention how to write the test. Like, for example, we don't, when we write end-to-end tests, we don't assert CSS selectors of text. We use the data test attributes. So, for example, our code is like data test vote button, data test whatever. So it's easier to write tests that don't break when you do a redesign. And when you do a redesign, you know, oh, there is that test here. That means that thing is used somewhere in a test. So we are focused on having a good test coverage. So we don't have big features. And right now, for example, we have the end of the quarter in the product, and we are planning the next 3 months. And during this time, we do something fun with engineering. Like last year, usually we do a hackathon. This year, we decided to do something called Bug Bash, where every engineer fixes a bug, and we are giving a prize, like we're giving a Golden Kitty Award, things we're giving for makers, we're giving it to the people who report it and the people who fix more bugs in the company. And I'm analyzing those bugs right now. Like people are fixing bugs, and I'm analyzing, okay, what are those bugs? What caused those bugs? What are the main issues here? And so far, to be honest, 90% of the bugs are UI visual bugs, like CSS, and from those 90%, 70-80% are bugs on mobile, like things don't align well. And this is something we are right now, I'm thinking around how to fix it on the architecture level. What kind of fixes people do? How can I fix that? And come back to like, okay, why this bug happened in the first place? It's not like be careful or do it better. This never works. Just I try to fix things on the system level. And I think I have some solutions to that. I'm thinking with my team and trying to show them, yeah, notice how much times you write an important exclamation mark. That means this is not a good abstracted thing. Let's see how we can fix that. And we are working on an internal design system called Dream for UI, which I think would solve a lot of those issues. So this is the way, again, trying to think about engineering being able to ship stuff fast. They need to have good foundational systems so they can focus on their task at hand and not so much of like, okay, now I have to deploy, I have to wait 4 hours. So another thing we do,
what about quality assurance? Do you have manual QAs?
So what we have is we have two things. We actually have three things for quality assurance. We have a lot of features we ship them feature flagged, so we can enable them just to group of users, usually admins. Those are the first guinea pigs. We have demo environments, so every engineer can just spin up our architecture. Is simple enough, so we can just ship it, just click a button and wait half an hour to boot the database and ship the whole system so we can test it. And we used an external QA agency. So we don't have QAs, manual QAs at the company. We used an external agency. It's called Lodestone. They're quite good. I'm really great people. I'm really happy with their work. So what they do is they do quality assurance in two ways. Like we tell them, okay, this is how a feature should work. But for me, the best thing they do is they, how do they call it? It's like they're finding things that are confusing and buggy. Like they found a lot of bugs that are not part of specification. Like what happens if I enter 10 text, which is like that, or 20 random clicks and stuff like that. So this is what we use for QA.
I see. So I'm going to return back about and have a question related to coverage. What is the coverage level on unit tests level, and what is the coverage level on feature tests level?
I don't know. To be honest, I don't track that as a metric. Like for me, is we just write the test. Like for me, every PR is like you should write tests for this. I don't count the percentage of test coverage. And the main reason for this is in JavaScript world, they're not very good tools. And the second thing is writing tests has two features, like the code design and making sure things work. And we very rarely have things that test, like missing tests would have catched. Most of, as I mentioned, most of our bugs are UI bugs. Very embarrassing UI bugs, but UI bugs nonetheless.
Okay. Okay. And what about code review? Do you have code review?
Oh yeah. Every code change should pass to code review.
And who reviews the code?
Everybody in the company. Like every engineer should review like ideally you should check half of the PRs. Most of the people don't. Like every PR usually gets like 2-3 reviews until just moving down the pipeline, but everybody is expected to review. Even like a junior engineer who just started, it's an amazing, like I love junior engineers who do PR reviews, especially if they ask, why is this so complicated? I don't understand it. Can you explain it to me? Because this often shows like this code is really complicated. Unfortunately, it's really hard to make people to ask, why is this so complicated? I don't understand it. This is something I try to work on with my team. It's like, if this looks complicated, try to figure out how we can simplify it.
I see. So thank you for the answer. I have a couple of questions. Do you have any interesting stories or issues what you faced with during the development? What you can share with us?
Yeah, so I can share two stories. Like one, it wasn't exactly related to us. It was somebody was DDoSing us. Like there was a lot of traffic trying to bring the system down. And this was the first time in my career I have seen like a DDoS attack, and we had to handle it. And it was, again, it was weird. I thought it was something internally to the system that happened, but then I saw the traffic, and a lot of the fixes for this were related to, again, Cloudflare saved our asses there. Like we were able to block started blocking whole countries just to be able to get up. And in the same time, we work with external DevOps agents called GoToAdmins. I work with them, with my team, to like, okay, let's add more servers here. Let's adjust some of that. Maybe we can turn off some of the features we're currently developing until this happens. Okay, talk with our support team, and our social team. Let's just write about that so our users don't worry about that. So it was a very coordinated effort, and it was like 6 hours of like, okay, just cat and mouse, like which is the good traffic, which is the bad traffic, which are the groups. And I learned quite a lot from this experience. I hope I don't see it again in my career, but I mean, we live to learn, right?
Do you have any lesson learned after the story?
So the things I learned, so I learned a lot of technical things that should have been done better. Like a lot was about monitoring and alerting. A lot of that was things that were missing. Uh, One thing I learned was that it was very important to have a coordinated response, not only on the engineering side, but to the social and the public persona of the company as well. Like the thing I learned was we shouldn't just, okay, we're just fixing that. We should tell the whole company what's going on so they don't feel worried. They should be focused. I learned a lot around handling this in general, like what are the steps. We've written a whole post-mortem about it, learnings, improvement, system improvements. And a lot of those are, again, very specific, very technical things.
So, and next one story? Or,
Yeah, so the other one is a bit more embarrassing because it was like done by us. And the problem was, this was not just, it was a long horror story. So the first time when we started working with, the first time when we fully switched to like a single page application, we started as a Rails monolith. So we just had like this Rails monolith and it was serving everything. And then we started adding JavaScript here and there, here and there, here and there. And then we switched to single page app where Google traffic is very important for us since most users are offline. So we needed to have a server-side rendering, and we built a server-side rendering for React. And the way we deployed it was, we were back then on Hero. So the way we switched that was, okay, we're going to boot a Rails server in a Heroku instance. We're going to boot an Node.js server in the same Heroku instance. We're going to boot an Nginx in the same service, and it's going to route traffic either from the node, either to the Rails. And this looks and sounds great. The problem, because we are like, oh yeah, the node is just going to call the Rails, they're in the same machine, that's going to work great. The problem is the usage patterns of Rails and Ruby compared to Node and our server-side rendering implementation is very different. Like Node can take a lot more traffic, just raw traffic, and hold it on that bus, while Rails depends a lot more. You need a bit more instances, a bit more beefy instances, and you're taking a lot more RAM here. So what happened was the Next.js server takes a lot of requests, stacks them up, and waits for the Rails, and Rails starts choking up. And we're basically DDoSing ourselves again because our front-end servers choke out our back-end servers, and we cannot scale the back-end servers independently. And the solution were provision a lot more servers in general, like in Heroku terms, they call them dynos, just a lot more containers with the whole system so we can take up the traffic. That was the time we actually added the caching in Cloudflare for the offline traffic, because a lot of our traffic is also bots. So this was for a couple of months. This was one of the ways then we changed to move to like AWS. And this was when we did a lot of that. But we were DDoSing ourselves, and we paid so much money to keep the system running unneededly. And what I learned from that experience was your system should be decoupled. You should be able to scale individual groups of your systems in a separate ways. Like, for example, right now we have one container for the backend, but it's split into groups, into separate domains. So each of those can be scaled individually. Like we have a public API, and this public API has its own set of servers, which if gets to choke up, okay, they choke up, but they don't drop the whole system. So I learned a lot around architecturing and coupling between services and testing assumptions. Like, oh yeah, Node is just going to one request Node, one request Rails, come back and later. But the usage patterns we had were a lot different. So that's a big learning from that experience.
So interesting story. Thank you for sharing. Probably last one question from my side, and we will move to questions from audience. Could you give some advice to engineers how to grow as an engineer, how to become a good engineer, in your opinion?
I actually have a blog post. It is focused on junior engineers, but to be honest, a lot of senior engineers can read it as well. And as I mentioned in the first part of the interview, you want to show you are reliable to your team. Like social skills and soft skills are very important, but the term here is you want to show you are reliable. You should show that you can ship code. You should deliver. You should deliver your tasks on time. And as an engineer, you should always focus to get to know the fundamentals. Like for me, technology, it's very rarely I see a technology that's fundamentally new. And those are really interesting. Those are really important for me. But I know a lot of programming languages, check a lot of technologies. So you always have to know a couple of layers above and below the stack you're working on. Like, for example, you might be a front-end engineer, but you should be able to explain why a SQL query can only use one index if it's not like a join and you don't do something more special. You should understand that because the same mental model you use for SQL queries is the same one you use for map reduces in the front end where you massage content. Because in the end of the day, the coding primitives like if, cycles, functions, communications is all the same. We just add layers of abstractions on top of it to make our job easier. And if you understand those layers of abstractions, you become a lot better. The third skills, because I'm going to share like the three things, like show you are reliable, know your fundamentals. The other one, and this is mostly for career growth, you will have to learn how to keep your tasks and Jira tickets clean. Like this is something that's going to move you far and beyond in your career more than any other skill. Is just keep on top of email, keep on top of Jira, keep on top of that, because you will be loved by your managers. They will adore developers that are very, very organized in the way they communicate forward to the rest of the company. So yeah, this is my advice.
Okay, thank you. Interesting. Let's move to the questions from audience. Can you read the questions? You can pick up
in the comments, right?
Yeah.
Yep, I'm seeing them.
Just pick. I will show it on our video.
Okay, so I'm seeing the first question is, what do you think about such technologies battle as Blazor versus JS, also Flutter versus React.Native? Yeah, I think those things are fun. Like it's always fun to compare technologies. And think about fundamentals. And the way I always compare technologies is two things: fundamentals. I also compare them into dependencies, like how much this technology depends. Is it very stable? How does it change? And how it can fit into my working environment. Like, for example, Flutter versus React.Native. I prefer React.Native and I use React.Native. I think Flutter fundamentally might be a better technology if it was used in isolation, but it's not. Like, we use React.Native mainly because everybody on my team knows React, so they can help. And Flutter is different. So this is something that makes sense in isolation. And there is always trade-offs. There is like, if you use Flutter, you are making good decisions. If you use React Native, you're making good decisions. If you are using Native, you're making good decisions. There is, in technologies, there is very rarely very bad decisions, and you are going to know about them.
Sometimes we did battle between different technologies in format of stream. If you going to battle with React Native versus Flutter, we can do it.
Yeah, I really like those. I really like those battle technologies. I have been part in a couple. I'm really bad at those because, to be honest, for me it's like very context dependent. Like I would say, yeah, Flutter is great. It's amazing. I'm agreeing with every point you give me. I can even give you more points why React Native sucks or stuff like that. But it's not very specific in terms of like what's the project you have to choose between those two. But I really like those discussions because you learn so much stuff that sucks about technologies, which is stuff that I think people don't talk much about. Like I was on a seminar called The Dark Side of React. And if you are on this panel, you would think I hate React as a technology. But just because I use it and I like it, I actually know so much things that are problematic about it. And that's the thing. There is nothing perfect. If there was something perfect, everybody was going to use it.
By the way, does it matter when you choose technology, who supports this technology? I mean, Facebook, Google, or probably community, size of community?
For me, it depends more around the history. Like, is this something that has like a longer history or shorter history? Like Salim Natalev's theory, like if a technology is used for 5 years, most probably it's going to be used for another 5. If technology is used for a year, would somebody else use it? So I check. So when I look at technologies, I look not who is supporting them, but also I look at their history. Like for example, one of the reasons I don't like Angular was they switch backward compatibility, and that's not the most valuable thing for them. While in React, they have the value that Facebook uses React, and they cannot make breaking changes, and that's great for me. I don't want breaking changes in the technologies I use just because. So I definitely look who stands below the technology, and also to think about the way I look at technologies is when you say technology, I don't think as one thing. It's a spectrum. Like React or TypeScript, those are foundational technologies. Like you build your apps on top of that. But for example, this small calendar library, it's not foundational, it's just a calendar library. It's very isolated in my system. Or which cloud I am. So the way I'm thinking about technology, I'm thinking them as dependencies. And I'm looking up their history, who supports them, and how important are they to my stack, how I can replace them if they don't work out. Like if, for example, React dies, I have to rewrite the whole application. That's quite bad. But for example, if Next.js tomorrow disappears, that's fine. I've isolated Next.js in my application. I need to change a lot of things around deployment, a lot of interfaces. If the calendar library we used last week doesn't have a feature, I'll just replace it. That's no deal. So I'm thinking around history and how big of a technology changes. Is it a whole new programming language? Is it for a monolith or for a microservice? Is it for internal microservice or external?
Okay, thank you. Last one question from audience.
Backupping, disaster recovery plan. So I mean, we have quite a bit of procedures around them, a lot of documentation around stuff. We have we have a smart way to test our database copies and stuff like that. Like right now we used a lot of managed services, which gives us a lot of things for free, like S3. Like, do you need to back up your S3 stuff? Like how much of it is guaranteed? A lot of protections in different areas. So we have a lot of disaster recovery plans. We have, like, for example, the way we test our database snapshots is every developer gets a copy of the production database with smaller version, obfuscated with no personal data and all that stuff. So what we have is every week, there is like, okay, we get the one snapshot, we put it in like an instance, clean it up, check if it works, everything boots, everything is there, that's great. Cut it down, make it a developer copy, and every developer uses it. So if this is broken, that means our database backup is broken. And that's easier to find out than just testing a lot of that stuff.
Okay. So, and last one question.
Okay, yeah. All right. Any thoughts on development evolution? What's going to be in 5 years? Which languages evolve? Oh yeah, that's a great question. So the thing with technologies is that we are always in cycles. Like we always go from compile to script to strong type to not strong type, and we go from procedural to functional to OPIT, and that's it. Right now, in the next 5 years, in my opinion, a lot of the focus would be into type safety. Like I think we finally are nailing the type safety systems. Like we have awesome languages like TypeScript, Swift. It's another language which I really like, and especially the newest version with actors is amazing. Like also, I like a lot of the work on those languages would be again type safety, compiler helping you standard. The other thing that's going to work is standardized outputs. Like Go has a built-in style guide, Elixir has a built-in style guide, Prettier is now the style guide of JavaScript, kind of. So a lot of that will be around automations like that. We are also, again, I mean, we are right now in the functional realm, but I think the actor model is going to become even more mainstream. Like Elixir is one of my this is a language which I would love to use at Product Hunt, but again, I love the technology, I like the language, but it's more like okay, why would we use it? Like Ruby is good enough for us, type of thing. And the actor model is something which Swift adds, and I think this would add a lot of mainstream and a lot of uses that people don't know. And we are just going to focus to have a bit more high level type systems with functional flavors and more things that the compiler would do for us. Like Rust is another example or like that. It's a bit more low level. It's better for C, but its compiler work is amazing. So I'm thinking a lot of work of engineers will be put down to compilers. I don't know yet. I still haven't tested the GitHub Autopilot and the AI generated code. I still don't. I would see how it works. I had some thoughts, but I'm not very sure. So for me, I think the next 5 years are like more of these more languages like that.
Do you have any move in Ruby world to type safe, something like?
So Ruby has this definition language for type safety. I haven't dig much into it. It's something I'm very interested in. With Ruby, I haven't felt the need, like the way I write Ruby, we almost never get like no method errors and stuff like that. So I think with Ruby, it would be very hard. And I see this with the implementation of the type system. It's very pragmatic. It has brilliant parts, but it's obvious that Ruby was not designed to have a system like that, and that's sure. Like TypeScript, for example, it's like amazing piece built on something that doesn't support that, but with JavaScript, it's a lot easier than make it type safe than Ruby.
Okay. So one more question from please.
All right. Could you please share your experience? Yeah. Oh man, that's a whole series of blog posts, meetings, and it's a very broad answer. And like, let me see how to compile it into something useful for people. Like one thing with my team is remote. So, and it's always have been remote, and I have like so many countries and cultures there. So the first thing for me, it's one of my favorite books is called Culture Map. And the book talks about the differences between different cultures and the differences in the way you communicate with them. And I'm very cognizant of this. One good example from the book is when you communicate with German people, and in Germany, you say, okay, this is the problem. This is how I get to the solution. This is some Q&A stuff around it. This is my solution, because they want to see the whole process. With the US and I always do that by instinct back then. But this is the problem. This is my solution. This is a Q&A. This is how this is my methodology and so on. So this is, I don't know which is better, but it's different in culture. So when you work with your team, the first thing I think about is culture, like different people. Also, the other thing is I want to understand what's the goal of my team and how this aligns with the company goals and how I can help them grow in those particular positions. With me, I kind of cheat quite a bit. Like most of my team members are people who want to make their own products and grow into that role. So this is the thing. It's something I need for the team. A lot of product mind engineers, and I try to give them some freedom there and try to balance a lot of that. So it's a very tricky question. I'm still learning the ropes of it. Every new person, like all the things, if I can come back 6 months ago, I would change so much things in the way I do this. And 3 months and 4 months, I'm still very much learning and growing here. The constants here are having a structure, having a log of the things this person did, give them feedback often in smaller chunks, and keep a log of this feedback. Like this is something I'm doing for the last couple of months. On every one-on-one, I have like a list of all the things you did great, very positive reinforcement, just because for people it's very useful to get positive feedback. Because a lot of people focus on the negatives. I'm a person who focuses a lot of the positives. It's called positive reinforcement. It's easy to reinforce behavior that's already existed. And if it's a good behavior, you reinforce it and you promote it even to the whole team. You give kudos to the people. Like, great, you did this thing. And the whole team sees, oh, this is a good behavior. This is the expected behavior here. And for the negatives, it's like, okay, how would you want to improve that? And I have this as a log every 2 weeks when I have the one-on-ones. So we can come back and say, oh, notice the last 3 weeks you are underperforming here. What's the issue? Or, oh, okay, you missed one meeting, but you have been on time the last 20 meetings. Okay, that's just a fluke. So those are kind of the two major things that you might take like here. One is check the culture map book and think about different coaches and the way they talk about, and positive reinforcement, and have feedback written down. So it's not like he said, she said situations.
Okay, I have one more question in my private chat. How to apply to Product Hunt development team?
Oh, yeah. So we will be hiring in a couple of weeks. So the way we work is we have bursts of hires. Then we spend 1 quarter hiring, 1 quarter onboarding, growing the team, making sure the people work. And this quarter we are going to do a hiring. So we are going to hire team leads for, again, the full stack things we are doing. We are going to build a whole new mobile team with mobile engineers. More probably we would even go native. I'm still discussing this. That's the reason we don't have the job offerings yet. We have to finalize them in the last couple of weeks, so you can check them in the video description down below. And we will most probably have a couple of more open positions for full stack engineers who are work on the tech stack I already explained.
So thank you for the interview. We'll waiting for links for positions and attach it to video description. That's it for today. Follow us on YouTube and on Telegram. Thank you, Radoslav, and have a good day to everybody.
Thank you too. It was quite fun. See you. Bye-bye.
Bye.